Professor Belfrost's science class is back.
Hi, welcome back to this channel. And today we'll again discuss another concepts related to science. So here's the science tutorial for you today. Are you ready? Let's continue playing this video. Okay, so welcome back. So yeah, things that we can continue on our next chapter, which is and yeah, what is dynamic? Okay, if before we have discussed about kinematics, so now we are introduced with new term in physics, which is dynamics. What is dynamics? Okay, so dynamics is, I'm sorry if there is a audio problem here. Okay, so dynamics, okay, so motion draws our attention. That motion itself can be, yeah, beautiful, blah 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 blah. Yeah, so the study of motion in kinematics, but kinematics only describe the way object move, their velocity and their acceleration, while dynamics consider the forces that affect the motion of moving objects and systems. And Newton's law of motion are the foundation of dynamics. Okay, so Isaac Newton's laws of motion was just one part of the monumental work that has made him legendary. Okay, and actually there are quite many efforts from the other scientists, the previous era scientists, to build this dynamics chapter. Okay, and you can read it by yourself here. Okay, there are many scientists' contribution that has been um, described here. Yeah, now we enter the first topic, which is development of force concept. So dynamics is the study of the forces that cause objects and systems to move. And our intuitive definition of force is that you push or pull. Yeah, but this is, yeah, not all of the definition of force that you will encounter in physics, but this is a good place to start. Okay, so we know that push or pull has both magnitude, okay, and direction. So it is vector, right? And yeah, vector quantity and can vary considerably in each regard. Okay, um, there are some intuitive example here. If two people push in different direction on a third person, as illustrated in this figure, okay, we might expect that the total force to be in the direction shown, because we have in the previous chapter we have learned about resultant. So we have F1 here, build the horizontal component, and F2 build the vertical component. So the resultant component is a little diagonal like this. This is the F total. Okay, you can use head to tail method or trigonometric methods or Pythagoras method. For this it is very easy. And yeah, this idea has been learned, has been discussed in the two-dimensional kinematics on the previous chapter, I mean. And this, okay, figure A can be drawn into this, and this describes the free body diagram. Okay, so the free body diagram is a technique used to illustrate all the external forces acting on a body. And a body is represented by a single isolated point or free body, and only those forces acting on the body from the outside are shown. So this is a very critical thing, that not all forces are drawn in the free body diagram, only the ones that are related to the body that we are examining that is drawn. Okay, A more quantitative definition of force can be based on some standard force, just as distance is measured in units relative to a stereo distance. That one possibility is to stretch a spring a certain fixed distance, as shown in figure 4.4. Okay, you see that the use of the force it exerts to pull itself back to its relaxed shape, called a restoring force, as a standard. Okay. Now, after this introduction, now let's examine about Newton's first law of motion, which is inertia. So actually, there are three laws, and the Newton's first law is about inertia. Okay. So please read this text on a box, inside a box. A body at rest remains at rest, or if in motion, remains in motion at a constant velocity unless acted on by a net external force. Okay, you see, remains. Okay, so this law can be regarded as preserving the status quo of motion. Okay, this law means that there must be a cause for there to be any change in velocity. Okay, consider what happens to an object sliding along a rough horizontal surface. The object quickly grinds to a halt, right? But if we spray the surface with a talcum powder to make the surface to become smoother, then the object will slide further because we have reduced the friction. And friction is the opposing force. That force, the force that we put in the or we apply to the object to slow down. Okay, and if we make the surface even smoother by rubbing lubricating oil on it, then the object slides further yet. Okay, so friction in this case is thus the cause of the slowing, and this is consistent. This is consistent with Newton's first law. Okay, and friction is an external force. Okay, so experiments have thoroughly verified that any change in velocity must be caused by an external force, and the idea of generally applicable or universal laws is important not only here, and it is a basic feature of all laws of physics. Okay, now we are considering the mass, and mass is one of many important units in physics. So the property of a body to remain at rest or to remain in motion with constant velocity is called inertia. And Newton's first law is often called the law of inertia. And as we know from experience that some of them have more inertia than others, that it means that it is more difficult to change the motion of a larger boulder than that of a basketball, for example, because it has larger mass. Okay, so the tendency of something become more difficult to be moved, it is inertia. It's described by inertia. So mass is a measure of the amount of stuff in something. Okay. Yeah. Let's check your understanding. Which has more mass, a kilogram of cotton balls or a kilogram of gold? More mass. The answer is both have the same mass, so they are equal. Okay, the quantity, the volume may be the same, may be different, I mean, but the mass is just the same. Okay. Now Newton's second law of motion, which is concept of a system. Okay, actually, yeah, this is F equals ma. Okay, the acceleration that we have discussed in the previous chapters. Okay, and this is closely related to Newton's first law of motion, and it mathematically states that the cause and effect relation between force and changes in motion. Okay, and this become very quantitative because the answer for the questions that we have faced so far is that a change in motion is equivalent to a change in velocity, and a change in velocity means by definition that there is an acceleration. So Newton's first law says that a net external force causes a change in motion, and thus we see that net external force causes an acceleration. Good. And another question immediately: force. Okay, what do you mean by external force? And external force acts from outside the system of interest. Forces are external. It's very important. Sometimes this is obvious, whereas other times is sometimes more subtle. You can see here. Okay, and I want you to learn how to sketch a free body diagram. You see, the system of interest in this case is this boy with this card. Okay, so this is one system actually. Okay, so you see, you have F1 to right. Okay, F2 from the second person to right too, and we have normal force upwards. We have the weight of the boy and the cart downwards. I have the friction to left, for example. Okay. So a smaller force causes a smaller acceleration than the larger force. Okay. And for completeness, that the vertical forces are also shown that they are assumed to cancel since there is no acceleration in the vertical direction in this case. Okay, it's not. This is only in this case. Later, you will find a problem that vertical forces are very important, and you need to take into account. And yeah, maybe you'll see the example later. Right now. So the vertical forces are the weight in this case, and the support of the ground, and I always call this the normal force. And the horizontal force F represent a force of friction. Ah. So friction is a force that opposes the motion past each other of objects they are touching. And acceleration are proportional to the net external force. Okay, so this means proportional to. And acceleration is inversely proportional to the mass. So, in summary, this is the second law of motion. So, Newton's second law of motion is acceleration is proportional to the net force and is inversely proportional to the mass, or it can be written in more familiar form, which is F equals ma. And if we only consider the magnitude, yeah, you can just omit the bold, okay, and make it italic. So F equals ma is used to define the unit of force in terms of three basic units: mass, length, and time. And the unit of force is called Newton, and Newton equals 1 kilogram meter per second square. Now, what is a weight? Weight is also actually a force, okay? So when an object is dropped, it accelerates toward the center of Earth, and Newton's second law states that the net force on an object is responsible for its acceleration. So if air resistance is negligible, then the net force on a falling object is the gravitational force, commonly known as weight, or is symbolized as W. Okay, it has direction, which is down by definition, the direction of gravity. So weight is basically, principally, a downward force. Okay, so you can see like this. And when the net external force on an object is its weight, then we say that this is a free fall. Okay, this means that the only force acting on the object is just the force of gravity. Yeah, sometimes we have we know that there is a term weightlessness or microgravity. Okay, and actually this is phenomenon we call free fall in physics. So weight is not described using kilograms, but it is newtons. Okay, mass should be kilogram and weight should be newton because weight is a force. Okay, I want you to take your time to pause this video first and read this common misconception part: mass versus weight, because mass and weight are both different terms. Okay, let's dive into the example. So suppose that an external force exerted on a lawnmower is 51 newtons, about 11 pounds, parallel to the ground, and the mass of the mower is 24 kilograms. So what is its acceleration? It's very easy, right? A equals F by F over m, so 51 divided by 24. And that's all. It is about 2.1 meter per second. Now, what rocket thrust accelerate this strength? Okay, so say there is a thrust force for rocket propulsion system, and the slight initial acceleration is 49 meter per second square, and the mass of system is 2100 kilograms, and the force of friction is 615. So you see, in horizontal, okay, because here we actually don't need to consider the vertical, because the vertical doesn't give any effect in our motion that we are interested in, which is the horizontal motion. So T minus F equals MA, right? And because there are four this what is propulsion system, okay, for rocket propulsion system, and this is for T minus F equals MA. So T equals MA plus F over 4, and this is the result: 2.6 times 10 to the power 4 newtons. Now, Newton's third law of motion. Yeah, this will be our last discussion for this video. System is symmetry in forces. Okay, so when one body exerts a force on another, the first also experiences a force equal in magnitude and opposite in direction. Okay, and this is to confirm the Newton's third law of motion. So this is the sentence. Whenever one body exerts a force on the second body, that the first body experiences a force is equal in magnitude and opposite in direction to the force that it exerts. And this law represents a certain symmetry in nature, that forces always occur in pairs, and one body cannot exert a force on another without experiencing a force itself. Or sometimes this law is loosely called acceleration, okay, where the force exerted in the action and the force experienced as a consequence in the reaction. Okay, you see, when we are trying to start swimming, we push the wall behind, so we apply a force to the wall, and the wall pushes us back, so we can dive to front. Okay, we can start swimming. Yeah, there's a reaction force in the rocket, which is called a thrust. Okay, and you can pay attention to the mechanism that I described in this page, to how this thrust actually works. Okay, actually this is quite a long explanation that you need to read it by yourself. Okay, just discuss the example. So a physics professor pushes a car demonstration equipment to a lecture hall Her mass is 65 kilograms, the cart is 12 kilograms, and the equipment is 7 kilograms. So calculate the acceleration produced when the professor exerts a backward force of 150 newtons on the floor. All forces opposing the motion, such as friction on the cart's wheels and air resistance, total 24 newtons. So we have a floor that push the professor to front. They have the professor force to the cart. Okay, the cart, yeah, certainly push back. This is action reaction. So we have this is system 1 and this is system 2. Okay, so the force that is exerted is 150, right? Okay, and there is the opposing force, the friction force, which is 24. So the horizontal force total is 126, and the total mass of the system is 65. This is the mass of the professor. Then the cart is 12, and the equipment is 7. So 65 plus 12 is 7 is 84. So the acceleration is 1.5 meter per second square. Now calculate the first professor exit on the cart using the data from previous example. So it's easy, right? The professor force is, yeah, the net force plus the friction force. We must calculate the net force first. The net force is MA. M is the system that's pushed by the professor. It means that the car and the equipment. So it is 19 times the acceleration, which is 1.5. So it's 29. So 29 times the 24. It means that the professor need to exert 53 newtons to make the car with the equipment to move with 1.5 meter per second square acceleration. Yeah, I think that's enough for this video. Okay, we'll continue next time. So before I end this video, I want to share you a quote. So Vince Lombardi once said, "It's not whether you get knocked down, it's whether you get up." That's the end of the video for today. Thanks for watching, thanks for following so far, and here's what you need to do. Please subscribe, give a thumbs up, comment, and share this video to your friend. And also, don't forget to check our website at https://science-with-exploits.uanaux.com, and I'll be back on every Tuesday, so keep watching and be thoughtful. Goodbye, see you on the next episode.